Okay, hello everyone. So this is a recording of chapter 16. We'll be talking about long-run exchange rates and their determination. This is basically going to be about PPP and then about real exchange rate after we assume that prices are not fixed. Right? So that's the main long-run assumption. And what we're going to be doing is using the money demand equals money supply equation to figure out the price level, and then later in each country, and using also the assumption that PPP holds initially to back out the nominal exchange rate from the fact that PPP holds. Of course, that isn't true, and so later we will, in reality, later we will assume that there is a deviation from PPP, which we will call the real exchange rate, and this real exchange rate may be determined by some real factors such as demand for New Zealand's products from overseas, or it could be determined by productivity in New Zealand or in another country, and we will talk about that and combine the two views. So the first one is basically going to be something called the monetary view, in which prices are flexible, and the second one is going to be combining the monetary view with this real exchange rate deviating from parity. And both of them will be aiming at figuring out what the nominal exchange rate should be doing in the long run. And in the process we also have to say something about how the interest rate differences behave, and there will be something called the Fisher parity or the Fisher effect, and you've already probably heard about it somewhere else, specifically in the second year economics or macroeconomics, if you had taken it. So we talked about the short run determination of nominal exchange rate, which was in our rather nice and also somewhat complicated diagram. Here we will relax the assumption, and this is kind of going in line with what the economists usually do, which is to assume different models for different questions on hand. So here we will be relaxing the assumption that prices are flexible. We'll assume that the long run is a sufficient amount of time for prices to adjust, so this will be something over 1.5 years or 1 year a little bit. Typically the median price adjustment or price rigidity estimate is 5 quarters, or 5 times 1 quarter of the year, so 1 year and 1 quarter basically. And because this is going to be about long run, will be expectations will also still play a role as they do in the short run. We'll start with law of one price, which is basically something that you probably are familiar with already, and if not, it's about individual good prices. So law of one price is of course not a law; it's just a name for a possibility that prices are equal for a given product, as opposed to the basket of products, after we convert them into the same currency. Now typically this doesn't hold, but we know why it doesn't hold, and there's a lot of studies, and there are lots and lots of studies in economics about law of one price. Just think about a pizza and assume that one restaurant has a pizza which costs $20, and then another one down the road or across a couple of hills in Auckland costs $40. So if these are sufficiently proximate, so they are literally across the road, and if these are roughly the same quality, it's unsustainable, this kind of a price difference. So what's going to happen is so-called arbitrage, and it's basically buy cheap, sell expensive. So if in this situation, probably the producer who's selling pizza for $20 is going to capture the whole market, so nobody's going to be buying stuff from the producer or from the restaurant which sells pizzas for $40. And if they want to stay afloat or in business, they'll have to lower their prices. And so this process is something which we would call a type of an arbitrage. Now typically arbitrage would be referring more to traded goods. In this case I'm just saying consumers will stop going to the expensive place. But if we're talking about an identical product sold across the street for different prices, it would make sense, or hypothetically at least, you can think of some consumer or some actually a company opening shop next to the other side, next to the expensive company, and all they would do is buy cheap and sell it for slightly less than the neighboring company, and that would result in an adjustment of prices on both sides of the street until they are approximately equal to each other. So there's a price adjustment process that we call arbitrage, and this arbitrage holds or should ensure that prices are reasonably close to each other. Of course, it's subject to a number of conditions. One was that these things places have to be close to each other. So transport costs. If transport costs increase, or the further you go, the lesser is the incentive for arbitrage, and also and consequently, the larger are the price differences between locations. So we can think about Pizza, Seattle, and Vancouver, so places that are about 4 hours drive apart, and you will have a similar kind of you will find in the data that the price differences are much larger than for price differences within a same city, or let alone on the same street. And so clearly transport costs are going to be an important determinant, and there will be other determinants. I'll mention them shortly. So PPP, which we have discussed earlier, purchasing power parity, is an application of a law of one price to all prices, or sorry, I should say to all goods and all services, or for representative baskets of goods and services. So if I take these law of one price differences for every single product and I add them up, you get a difference in prices for a whole basket of products, basically, on average. If you weigh them by their equal share, you'll get the equal weighted average price difference, and if you weigh them by their expenditure share, you'll get an expenditure weighted price difference. And if you just want to express this mathematically, you would just say price basket of in the US is approximately equal to, well, in this case exactly equal to the price of Canadian basket after we convert it to the US dollars. So we need to convert the prices of two baskets into the same currency, and that's just the PPP. And you would literally try to calculate, and people try to do this, prices of baskets of products that consumers purchase in every country. These may be small or completely comprehensive, such as the one that you would calculate using the consumer price index. And then, if you know the prices, you can rewrite the equation from the previous page to express the nominal exchange rate. So the exchange rate can be written as a ratio of prices in the two countries, in the home relative to the foreign country. Now this only holds, of course, if PPP indeed does hold, and we know that PPP does not hold, but there are two versions of PPP. One is the absolute or the strict form, the absolute PPP, which assumes that prices hold exactly, or price parity holds exactly for groups of products in the two countries. So nominal exchange rate then has to be equal to this. And the second one is a little bit more relaxed, which is the one which is actually true, and it's called the relative PPP. And what this says is basically, we know there are differences between prices or baskets of baskets of products and services between countries. But let's just say, but let's assume, this relative PPP assumes that these differences do not vary. So let's say if Australia is 10% more expensive on average, this PPP will fail, clearly, because the prices of baskets of goods and services are not the same when expressed into the same currency. But let's say that this difference of 10% doesn't change very much over time. So it stays around 10% more expensive. Or it could be New Zealand that is 10% more expensive. Actually, it's probably more New Zealand that is 10% more expensive. So let's just say New Zealand is 10% more expensive, and this price difference doesn't change over time very much. Then we could say that okay, although PPP in absolute sense doesn't hold, we can, whenever we see a price increase in one country, we would see a price increase in another country of the same percentage. So in other words, the equation, this equation here, although it does not hold in levels, will hold in changes. Okay, so whenever one currency appreciates, whenever prices increase in the home market, compared to the increase of prices in the foreign market, that will be represented by an exchange rate depreciation. okay? Or an exchange rate change, which we know is a depreciation. So we can express it instead of levels in changes. Change of prices, of course, is inflation, and change in nominal exchange rate is just the nominal rate, the rate of nominal exchange rate depreciation. This is called the monetary approach. So we will be basically using this equation here either in the absolute form or in the relative form, and we will use money supply equilibrium, so money market equilibrium, to express these prices on both sides, home and foreign price level. So the money market equilibrium is just our good old-fashioned expression that money supply in real terms, it's not written on this slide, but you can remember it's money supply in real terms equals real money demand. There's this L, which depends on interest rates and output or income. So we can rewrite that equation to get these expressions for prices as equal to money supply divided by real money demand. Okay, so if both price levels in both countries are represented by these equations, we can write the nominal exchange rate as a simple ratio of these two terms on the right hand side. Right, so there are a number of points in these terms. First one is the money supply. So, all of this is going to be familiar because we discussed it in chapter 15. Basically, if the money supply goes up, what's going to happen? The home nominator is going to increase, and so the nominal exchange rate will have to increase, which is a depreciation. Right, so permanent increase in the domestic money supply and causes proportional increase in the domestic price level. Right, that's just represented by this equation here, that P is if L is fixed, an increase in M is resulting in an increase in P of the same proportion, and consequently we have an increase in E of the same proportion. So that's a depreciation of the domestic currency through the PPP. And then if interest rates go up, you can similarly trace it this way. So if interest rates go up, the demand for real money balances or transaction demand goes down, and therefore the ratio increases, and we have a higher price level at home. Everything else being fixed, this results or this requires a depreciation or an increase in nominal exchange rate. Now this is somewhat counterintuitive, of course, because I mean, if you think about it, typically when we see what we used to say before was when interest rates rose, we had a higher return at home, and therefore we had an appreciation of the currency, right? But remember here, that was the cause of that was actually monetary policy tightening in the short-run story, right? Whereas here we're assuming that interest rates are changing ceteris paribus or nothing else, so there's no monetary policy changing, it's just somehow interest rates are changing. So it's somewhat, I would not bother remembering this point too, because we know interest rates are actually not an exogenous variable as is being assumed in this point too, but they are a result of some kind of a money market equilibrium. But here we're in the long run, we're kind of ignoring money market equilibrium, so we are just saying interest rates somehow come exogenously. Alright, finally we can think about the output, which makes perfect sense. So if there's an increase in demand for real money balances because output went up, the denominator will rise in domestic production. Yeah, so there's a increase in demand. Therefore, there is a shrinkage in the ratio, which is the price level. So prices go down, and hence E has to go down also, which is an appreciation of the currency. Okay, so all three of these can be traced to changes in nominal exchange rate, holding or assuming that prices are completely flexible, and all of that is coming from the assumption that PPP holds. I could talk about exactly the same thing in differences or in percentage changes, basically. So the same equation that I started with can be expressed in percentage changes, which is the relative PPP, and then and these two can be expressed in percentage changes. So inflation rate is equal to the percentage growth in money supply minus the percentage growth in the real money demand, which could be coming from interest rates or output growth. So we could express this in relative sense and get exactly the same kind of prediction. So growth rate of money supply implies an increase in growth rate of inflation of proportionate amount, and that results in an increase in the rate of depreciation, everything else being the same. Now, one thing we are ignoring so far is the determinant, as I mentioned in this part here, is where the interest rates come from. There's an additional story in the long run. So remember the parity, of course, interest rate parity. So that's what we used in the short run, or was a result of a short run assumption about arbitrage. In the long run, prices are fixed, and so we can rewrite that equation. Basically, we can do one more step and say if we express nominal exchange rate depreciation using the monetary approach, we can see that it's basically proportional or equal to inflation differential, and holding everything else constant again. So this is somewhat, I'm not a huge fan of the Fisher effect because it assumes so much, but it's a long run condition which tells us that we can replace exchange rate depreciation with interest rate differential. Right? So if I go back, we can express exchange rate depreciation with inflation differential. Of course, inflation differential itself is not, so the difference in rate of growth of these two prices is not exogenous. We can see it from here. So it's coming from money supplies and interest rates themselves and output, but all of that is being ignored. Anyway, in the Fisher effect, which you will need to remember, wink wink, so I mean this is stuff that is kind of very fundamental in macroeconomics. So if you replace exchange rate depreciation with interest rate differential, you get the Fisher effect, which is interest rate differential is basically equal to inflation differential. Okay, so a domestic inflation rate increases will just transpire or translate into interest rates increases relative to another country. Alright, so now let's do a few sort of thought experiments, but it's already quite obvious. So if the growth rate of the US money supply increases, what's going to happen is inflation rate is going to increase by the same amount at the same period of time. So this is again a long run approach. So we assume prices are not rigid; they immediately adjust. Let's say the foreign country, in this case Europe, doesn't do anything, so it's staying at 0%. So if inflation jumps up, it means that if inflation rises from pi to pi plus delta pi, Fisher effect on the previous slide is telling us exactly the same thing is happening with interest rates. So higher interest rates are offsetting this higher level of inflation. So I'm going to be plotting these things. So I'll just say money supply goes at certain slope before the change in growth rate, and then it rises at a higher slope. And the slope is exactly the same as inflation, so it's pi initially and then pi plus delta pi after the money supply growth rate rises. And the interest rate that is associated with it also has to jump 1 for 1, so it jumps by the same amount. Now you might ask what happens to prices. So remember this equation. I'll go back a few slides. So remember this equation. So initially, at the time when money growth rate is increased, money supply is still at the same level. So that hasn't, it starts growing at a faster rate, but at the time when they make the announcement, there's nothing happening to the money supply. It keeps on, it's basically at the same level. It doesn't jump. That's the important part. But at the same time, we said the interest rate has to jump up by the same rate as by the same amount as the increase in the rate of inflation, so delta pi. So if this jumps up, then the L has to jump up, and therefore price has to jump down because the L is in the denominator. Okay, so that's I'm trying to explain why is it that prices have to jump up by the same amount. So the domestic price level, because did I say down before? Anyway, it's up. The reason why it's up is the interest rates rise. Okay, that's from the previous slide. Interest rates rise, and therefore people demand less money, less transactions. So the money demand goes down, and nothing happened to the money supply. So the ratio has to go up of them because demand for real money balances is in the denominator, and therefore price level has to rise or jump. So price level jumps, and since price level is immediately linked 1 for 1 to exchange rate, so the exchange rate jumps as well. So we have this jumping sort of going on in the long run model as well. you will remember the short run overshooting, so that's something that you have to know because it's going to be on the exam. But and it's also an important aspect of international economics. Why do exchange rate overshoot their long run values, and how does that come about? But here we are just saying, okay, there's jumping going on in the nominal exchange rate, also in the long run approach, but I don't think it's really that realistic. I mean, just think about why that is a difficult sort of thing to swallow here. A long run approach is supposed to be about long run, sort of when prices are fixed, and the jumping is happening on impact, if you like, immediately after the announcement, where surely prices are not flexible at that point of time. So the long run approach is really not going to tell us that much about the immediate impact of or the consequences of the immediate announcement of an increase in the money supply growth rate. But anyway, that's what it says. So you need to know the analysis. Okay, so I already explained this. It's all on this slide as well. Okay, these slides are actually not posted, these three, as you can see, they're crossed out. Alright, so the shortcomings of PPP, well, the main one is it actually doesn't hold in the real world, which is a pretty major shortcoming if you ask me. But the relative PPP is reasonably supported by the data, unlike the absolute PPP. Okay, so there is a lot of work done on this, and I could kind of talk about it for hours, but I'm not going to. I recommend you read this chapter. It's quite interesting, and it has all these chapters have a lot more than I talk about, because they have they take a lot longer to read than 1 hour, and there's a lot of information, and it's a lot of interesting information. So they write stuff that is very much relevant and quite empirical, which is both relevant and interesting to read. So I strongly recommend that you do read those chapters. But there's one main regularity about PPP, which is, okay, it doesn't hold, but it doesn't hold more, if you like, for the rich countries. So the price levels are higher for rich countries than they are in the poor countries. Excuse me. And that's not always the case, but it's generally speaking the case. Let me just take a breather here. Alright, so back to this. Shortcomings of PPP primarily doesn't hold. Why does it not hold? Well, different people, different countries consume different baskets. So one question is, how do we compare the consumption basket in India and the consumption basket in France? Surely there's a lot more baguettes and a lot more French cars. Well, those are, let's just say Ferraris being consumed in France than in India. And these things cost different amounts, and obviously India has a completely different consumption basket also. How do you compare these prices of different types of products? And that's a good point, and that's something that we cannot get around really, to the extent that people consume different stuff. Well, it's not surprising that they cost different amounts, but nevertheless, on average, it is true that prices are higher in the more in the richer countries. And the question is why? Well, we'll have two theories that you will need to know coming up shortly. Here's one example. So, we have the nominal exchange rate, the red line, US-Japan, so countries of very similar economic level of development, and the ratio of prices between them. So the two should be the same amount, and you can see that in the long run they seem to go in the same direction and they have the same trend. So in the long run you could say, well, on average they kind of are at the same level, and therefore you could say, well, Japan is gradually becoming cheaper compared to the US, or in fact it started by being twice as expensive and it converges to being around the same price level as the US. In fact, Japan is a little bit cheaper than the US if you've been. So, or roughly the same maybe. Okay, so although this does not hold, the two are not the same, the two lines are not the same every year as the PPP would predict, they are generally speaking going in the same direction. So in differences, or relative PPP would be much more likely to hold over longer horizons, but even the absolute PPP in this case over long horizons is more or less satisfied. But that is only because we are looking at countries which have the same level of economic development. So nominally speaking, if you want to split it up into reasons, first of all, there are trade barriers and there are non-tradable products. So even the goods that are traded, for arbitrage to hold, we would have to for arbitrage to bring prices together, we would have to have trade occurring, and the trade is costly. So the cost of trade and transport will create a buffer around prices so that they do not need to be equalized necessarily, even if they are fully traded products. And then there are products that are never traded, the non-traded products, and for these there is no reason for arbitrage to converge or to induce a convergence of their price levels. So that's one big reason. The second one is imperfect competition, and that's something that we know in New Zealand very, very closely, because New Zealand has a low level of competition, and the reason why we have a low level of competition is we are too small and we are very distant. So the market is small, which gives rise to monopolies. Simply there isn't, with fixed cost, and remember trade theory with increasing returns to scale, and with entry costs, what you end up having is basically very few companies entering New Zealand because it's just not lucrative enough, and this gives them the market power, and this gives them high markups, which gives us, as the consumers, high level of prices. Okay, so imperfect competition. And finally, differences in the measures of average prices for baskets and goods and services. So, well, you can measure things differently, but I think the first two are the main ones. And the third one is, I guess, the composition of the baskets are different, actually. Okay, trade barriers. I think I discussed all of this actually already, but so the trade barriers are not just the shipping costs. There are also restrictions to trade. There are tariffs and quotas, which we know from the first half of the course. Services, although we say non-traded goods and services, we know, living in New Zealand, that a lot of services can be traded. I mean, some of you are foreign students. You are consuming a New Zealand service. So this service, education, is actually a traded service. Likewise, tourism is a huge component of New Zealand's export and is a traded service. Financial services, a lot of people bank, well, maybe there were a lot of rich people bank in overseas banks. This is again a traded service. So for many countries, I had a slide for another course which I couldn't find immediately, but for many countries in Europe, the share of trade is larger for services than it is for goods. And of course, these would be sort of hubs like Luxembourg, which is a financial hub. But nevertheless, service trade is very large. So, which is why the TPP and TTIP trade agreements are sort of trying to cater to the service side of trade a lot more. Of course, service is a lot harder to police because it's not something that shows up at the border, and the person who's screening border goods coming across the border can look at it and quantify it and say, well, this is how much tariff you're going to pay. Services are not mobile, so they're the transactions are much more difficult to police. All right, so transport costs thought of more, trade barriers cost or trade costs thought of more generally, not just the actual cost of shipping, and they include the government's red tape. Imperfect competition, so this may result in something we call the pricing to market. So it goes in conjunction with the straight cost idea. So pricing to market is a really major explanatory theory in international economics. It's a theory which argues that companies have the ability to segment markets into different categories. Well, to segment markets because the markets themselves, think countries, are not easily arbitrageable, if you like. So it's if you are Porsche and you are selling cars to New Zealand and to Australia, you can set different prices. You can segment these two markets because the consumers in those countries are unable to easily just arbitrage these cars over the border. First of all, the distance and the shipping cost, but also regulation and warranties. People are unwilling to take risks to kind of void the warranty by buying the car in another country and shipping it to your own country. So this gives firm the power to sort of segment markets and price to the market's specifications. So in the case of New Zealand, I'm sure if you know much about cars, you will notice that New Zealand price level for cars is much higher. Part of it is than Australia. Part of it is because of the lack of competition and the ability, to by the retailers and by the companies to set higher prices. The consequence, in any case, for our point of view, is that prices are not equalized between locations. Different baskets of goods. Okay, we discussed that. Hamburgers. So you probably have heard of the Big Mac Index. It's created by The Economist, the magazine. I'll post a link online, but basically it measures deviations from PPP by simply comparing prices of Big Macs. And which is a type of a hamburger in a McDonald's restaurant. So it's somewhat rudimentary, but it's surprising how precise estimates they get when it comes to comparing currency overvaluation and undervaluation, right? So in this case, we're going to be, you can see that there's some actual exchange rate, and they look at the prices of these Big Macs in different currencies. So US is the base here, and comparing it to Argentinian price, which is 19 pesos. In US dollars, it's $3.82. So this gives you some kind of a level of all right. So the actual exchange rate. So right. So then they look at the implied PPP of the dollar. So this is always divided by the US. So and compare it to the actual exchange rate, which is 4.98. And they can calculate that there's some kind of an undervaluation of the Australian peso. Specifically, this is lower by about 12.6%, as you can see. So the peso is overvalued. So in other words, they just compare the prices of these things in the same currency and use that. This is literally using the equation that we have just discussed early, the PPP equation, to calculate the correct, if you like, exchange rate. And they compare it to the actual exchange rate, and they say, is the actual exchange rate overvalued or undervalued by what percent? New Zealand is usually pretty bang on. So yeah, -1%. So in other words, the Big Mac is being priced roughly the same in New Zealand as it is in the US when it's converted to the same currency. All right, so this is the big picture, and this is the important sort of story here, is that if we stack countries, each dot is a country, by their income, we see that the prices are increasing with income on average, and this is converted to the same currency, so this is all relative to the US. We don't have the names here, but anyways, this is, there are books and books and books written about this, and it's kind of a no-brainer. If you've traveled, if you're from overseas, you are aware of the fact that poorer countries have lower prices than the richer countries. Why is this? So there are two main theories, and you will need to know these. Okay, so first of all, the empirical regularity, or the founding point that gives these theories traction, is that empirically speaking, the main reason why these price levels are different is that the non-traded prices, as opposed to the traded prices, are much different between countries. So the non-traded prices are much higher in the rich countries and much lower in the poor countries. And the question is, why is this? So there are two leading theories here. They both have the same mechanism at the end, and they both explain this in a sense, but they have very different assumption about what is the root cause of this difference. So the Balassa-Samuelson theory is just telling us that the labor force in the traded sector is a lot more productive in the rich countries than the labor force than in the poor countries. And by giving, and that could be for a number of reasons. So the theory doesn't really give you the reason immediately, but it could be that the technology is more readily available in the rich countries. It could be that the workers have better skills or better training. It could be that they have access to different, it could be the institutional differences. They don't really say. They just say, we observe this higher level of productivity in traded sector in the richer countries. And then the chain of events is kind of pretty obvious. So it implies that their wages are higher in traded sector. So if any worker is more productive, our standard theory is saying that inputs in production get paid their marginal returns, if you like. Well, for a worker, which is, we can think about it as labor being input into production, they're getting paid their marginal return, which is marginal product of labor. And if they are very highly productive, that means that the wages that these guys are getting paid are going to be high. Right? So wages are higher. And then secondly, traded, non-traded sectors, although we are so far describing just traded sector, the non-traded sector workers, they live in the same country, so the wages get pushed up in one sector, that draws up wages in another sector also, because workers can migrate between these sectors. So this fact that the traded sector is becoming more productive raises wages in both sectors, in fact, in the whole economy, right? So that's the second point. And that pushes up the prices of the non-traded goods, simply because non-traded sector has to pay higher wages also, and they are not getting more productive, so how can they compensate for these rising costs? Well, they push up the prices of their products, so the non-traded prices become more expensive, and hence we have high price level in the rich countries. The other theory is three guys, so this is an older one. the Bala-Samuelson is from the 60s. Bhagwati-Kravis and Lipsy theory is a little bit later, and they basically start by saying, well, rich countries have more capital than labor, so the capital-labor ratio is much higher in the rich countries, which is also true. Both of these assumptions, by the way, are true. And this implies, so if you have a lot of capital, so relative to worker, one way to think about it is to say, well, these workers in the rich countries have a lot more capital stock to work with, and that's something that you observe if you come from Europe to New Zealand. Although New Zealand is a developed country, but you see immediately that instead of the roads are being constructed by mostly by men with one machine, as opposed to elsewhere in the rich countries where you would see the ratio would be much more skewed towards the capital. There would be a lot more machinery around, whereas here you have mostly workers. And New Zealand, in the OECD bloc, New Zealand is kind of in the bottom half in terms of income. So it kind of, if you are coming with that perspective, it fits the data. And if you go to Hong Kong, for example, then everything is covered with concrete and there are machines everywhere. So it's a very rich country, or Singapore, as opposed to going to Argentina, where there's the capital stock is a lot more dilapidated. Right, so let's just buy that assumption. Let's say that the rich countries do have indeed a higher capital labor ratio than the poor countries. Now with that assumption, as I said, the workers in the rich countries have more capital stock to work with. That makes them more productive. So the marginal product of labor is actually higher if you have a more capital stock to work with. That's just a direct consequence of simple production function. And then the rest is actually the same as in the first theory, namely, these workers are more productive for a different reason. Here it's because they have higher capital to labor ratio, more capital to work with for every worker. Therefore, they're getting higher wages. And this theory is not specific to a traded sector. It's specific to any sector or every sector, basically. So the wages are higher, and hence prices are higher, and particularly non-tradable prices are higher. The reason why particularly non-tradable prices are higher is that the traded prices are kind of linked internationally anyway, because they are traded by assumption. So, you can't have the car prices can only go up so much relative to, for us, for example, relative to Australia. I mean, yes, it is true that our car prices are higher, but if somebody tries to sell cars for triple the prices than in Australia, well, although it is difficult and tedious, people would start importing cars from Australia and just ignoring this seller domestically, right? So there is a limit to how far these traded prices can go up, whereas non-traded prices, they can go up as you can't trade them. So I mean, if you have to go to a hospital, it's very difficult for you to bring the hospital from Australia. Okay, you can go to Australian hospital, but it's really difficult to do that and very expensive. So these non-traded prices can move up and down a lot more independently of what the other countries are doing. So it's primarily a story about non-traded goods. So prices go up in rich countries. So this is something that you need to know. Okay, now the last part here is about real exchange rate approach to nominal exchange rates. So it sounds like I'm just saying the same thing twice, but actually not. So a real exchange rate is defined by this equation here, right? So it's a pretty straightforward equation. Q for real exchange rate is nominal times the ratio of prices. So we think about this as a price of a basket of goods and services. All right, and the real depreciation and real appreciation are simply saying what is happening to the purchasing power in one country relative to another country. So the real exchange rate approach just expresses nominal exchange rate from the real exchange rate definition and says, well, nominal is equal to ratio of prices times the real exchange rate difference, or real exchange rate, basically. So if PPP holds, and I go back, then this is equal to 1. Right? So Q is equal to 1. So if PPP holds, then we have the same thing as we had before, namely E equals ratio of prices. But PPP doesn't need to hold, and one reason is this Balassa-Samuelson or Bhagwati-Kravis-Lipsy are both telling us prices are not going to be equalized, price levels. So if PPP doesn't hold for some reason, then Q is not going to be equal to 1. So that's the rest of this slides, and I'm going to upload them later today. But basically the rest of the slide is going to telling us, well, what are the possible reasons why Q may differ from 1, and then you can have theories which are going to tell us, well, or predictions about when in this more general approach, which we call the real exchange rate approach, as opposed to PPP or monetary approach. In this real exchange rate approach, nominal exchange rate may deviate for 2 reasons. One is the monetary reason, which is what we already described. The other one is the real reason, which is something that it could move, like productivity or demand for your stuff, which could be moving this Q. Alright, so that's it for now, and more coming today. Stop.